Hello, everyone, and welcome to Indoor Air Quality, Health and Passive House Design Explored. Just a reminder, everyone is muted with video off, but you can use the Q&A feature to ask questions to our panelists throughout the session, and we'll also be bringing them up for Q&A at the very end. You can also use chat if you want to have any side or general discussion with each other or the panelists. Thank you again to all of our sponsors. Make sure to meet them in the virtual expo hall. And before we get started with today's session, we will be hearing brief messages from our sponsors, Mitsubishi Electric and Alpen High Performance Products.
Your thermostat's set to 72, but it feels too cold in the basement and too warm in your bedroom. So you accept breaking out blankets or turning on fans as the only solution. But your system is just doing what it was designed to, sensing temperature at the main level thermostat. With Mitsubishi Electric Zoned Comfort Solutions, room-by-room temperature control is at your fingertips. With temperature sensed at each of the indoor units, constant comfort is now a reality. Put away the blankets, turn off the fans, and make yourself comfortable. You'll always want the latest technology, even knowing it'll soon be outdated. But for some reason, when it comes to cooling and heating your home, you haven't sought the latest innovation. The technology in your house is virtually the same as your parents and their parents. Mitsubishi Electric Zoned Comfort Solutions are completely changing the way you cool and heat your home. Tomorrow's technology is available today. Stop accepting yesterday's technology and make yourself comfortable. Imagine driving your car like you operate your home's cooling and heating system. You'd either keep the pedal to the metal or foot off the gas. Why is the constant on-off wear and tear on your cooling and heating system something you just accept? With Mitsubishi Electric Zoned Comfort Solutions, put your comfort in constant cruise control. Our industry-leading variable speed inverter-driven compressor steadily provides precise cooling and heating in each room or zone. Stop guzzling gas with yesterday's technology. Be greener and make yourself comfortable.
Almost a decade ago, when the early pioneers in the rapidly growing North American passive house community were eagerly asking North American window manufacturers to go above and beyond the status quo and provide independently verified window performance data they needed for passive house planning software, the request was either ignored or major U.S. manufacturers sat in big marketing meetings in fancy offices and asked, what is passive house and why do we care? At Alpen, we jumped right in and became the first U.S. window manufacturer to make the investment to get the window performance data the passive house community needed. Others eventually followed. We also became the first North American manufacturer to have verified data published in both the FIAS and PHI databases for our windows. We've spent 40 years innovating, improving, listening, and responding to customers on our mission of creating the world's highest performance windows. I'm Brad Began, CEO of Alpen High Performance Products, asking, what can we do for you to meet your needs better?
Thank you again to Alpen High Performance Products and Mitsubishi Electric. And with that, I will introduce our speakers. So we have Timmy Aziz, professor at the Maryland Institute College of Art, Department of Architectural Design, Monty Poulsen, passive house specialist at RDH Building Science, Inc., and Tom Phillips, formerly Senior Development Manager at the Seattle Housing Authority. Here are the learning objectives, and if you have any questions about that, you can go to the homepage of the conference and see that it is worth FIAS, PHI, AIA, and GBCI credit. Thank you again for joining us today, and don't forget to use the Q&A to ask questions of our panelists. And now I will turn it over to them to get us started.
Hi, I'm Timmy Aziz, and I'm delighted that we have today's session on indoor air quality, health, and passive house. I will be providing an overview of how passive house design might benefit resident health. That's the plan of my presentation. And while you look at it, just wanted to mention that I discovered passive house design and immediately became passionate about it, teaching it to my students, becoming a CP8C myself. It's exciting that a building design methodology can dramatically reduce the carbon footprint of buildings, but equally massive to my mind is the possibility that passive house could also benefit the wellness and health of its residents. I think asthma is the area where passive house can make its greatest positive health impact, to the best of my knowledge, and so you'll find me talking about it a lot. My motivation is much to further the cause of passive house as it is to also my fellow citizens' well-being. And on that note, I'll also be using Baltimore, where I live and work, as a case study, and our city's conditions are sure to be found in many cities across the country. Let me start sharing a little story. A few months ago, I was invited to a workshop for community land trust organizers that included several not-for-profit developers. I introduced myself as being an advocate for passive house design, explaining its reduced greenhouse gas emissions and the relief of utility burdens for residents, when a friend, Greg, reminded me to speak to the health benefits of passive house, something we discussed previously. I did so, talking about how indoor air quality is primed to help respiratory illnesses like asthma. And that's when I noticed that as the topic went to health benefits, faces in the room seemed to perk up. There was a different and more tangible interest in passive house. That's when I realized that people really get the idea that a great design methodology like passive house for buildings should also benefit the health of its residents. This for me was a game-changing realization that health is a major area of public interest for passive house and is still relatively unexplored. And it is no wonder that for Baltimoreans involved with affordable housing, the mention of, and community development, the mention of asthma would be attention-grabbing. A study done by the Environmental Integrity Project and ABLE Foundation found that Baltimore has 3 times the national rate of asthma hospitalization and twice the rate of the state of Maryland. The same report had a few spatial analyses that I think is quite informative for us. On the screen on the left, we see the toxic air risk map that is taken, I believe, from the EPA's EJ Screen information system. And on the right, we see asthma hospitalization rates, which sort of give you a metric of how bad asthma is in certain neighborhoods. And certainly there's a correlation between the red areas on the left and the dark blue areas on the right, indicating that high toxic air goes with high asthma rates. Mapping PM 2.5 particulate matter from traffic shows concentrations also coinciding with asthma hospitalization rates on the right. And in this slide, asthma prevalence is on the left, median income is on the right. Median income was found to have a strong correlation with asthma hospitalization. The low-income communities who have the worst living conditions in the city, and in Baltimore, these communities are predominantly African-American, are clearly who suffer the most from asthma. In Baltimore City, the hospitalization rate for asthma was approximately 2.9 times higher for Black residents compared to white residents. So how can passive house design help? There seems to be a consensus that passive house is good for health. But what do we know for a fact? Do we not need research to establish this as a fact? The article I'm showing on the right here is an Australian online paper, typical of the kinds of claims and informed hunches that we seem to be going on. But in order to go beyond anecdote, hunch, and conjecture to evidence and substantiated claim, we need a grounding in research and science, as well as studies of passive house buildings and their impacts, the health impacts on residents. Has there been any research or investigation that's been done that could help substantiate such a claim? What area of health could passive house play a critical role in, and how? Looking at various studies related to this area of concern, I found a study that compares the indoor air quality of two passive homes in London in 2012 and compared it with non-passive homes nearby. Temperature, humidity, CO2 levels, etc. were measured, as well as particulate matter. A cool part of this study was that resident habits were studied in detail, of window opening, clothes drying, taking showers. In the diagram that's shown, the diagram for a month of one of the buildings, the cause of the spikes in humidity and hot water were thus identified very clearly. However, the problem with the study is that the authors were interested in building performance and not that of the residents. And so the impact of indoor environment on resident health was really not studied nor correlated to the data. Of the few studies of passive house homes and resident well-being, a focus was that I found. A focus was on verifying that a dependency on heat recovery ventilation provided a good, healthy environment. The two studies that I found confirmed that this using subjective evaluations of the well-being of residents. No studies that I found actually examined the well-being of asthmatic residents in passive homes, interestingly enough. Two studies that overtly went about constructing indoor environments to help asthmatic residents came across my research, and one we will hear from Tom Phillips is the Breathe Easy project in Seattle. And a few years before that, a study in the UK where homes of asthmatic children were fitted with heat recovery ventilation and where symptoms were then found to be reduced. I hope I have the dates correct there, but in any case, Tom will set me straight in a few minutes. There are many studies investigating connections between the environment and asthma, the environment in general. In a paper on childhood asthma and environmental interventions, authors Wu and Takaro point out that we spend 90% of our time indoors, 66% of which are at home. In the indoor environment, they identify health critical contaminants, both biological and industrial, as well as dampness that can trigger asthma. The cost of care of environmentally attributable child asthma throughout the country stood at an amazing $2.3 billion, I believe in 2005 dollar values, and presumably is much higher today. In general, asthma is remarkably widespread and common, but the highest incidence of asthma lies in developed countries. The US was in the 6 to 8% category in the 90s, went up to 8 to 10 in the early 2000s, and came down a little bit to current days levels. Given that the way asthma is defined makes for variations in how it's counted, the CDC places most states in the US between 8 or above 10% of asthma occurrence. That is actually a very large number of people suffering from asthma. The National Council on Healthy Homes reckons that 26.5 million people in the US, that's 1 in 12 children and adults, suffer from asthma. So what are the basic facts of asthma that we might need to know? Asthma is a problem with our respiratory function. It's non-communicable, but at the same time, it's not curable. The breathing pathways are constricted by reflex or allergic reaction. We have no control over the kinds of smooth muscles wrapping around our breathing airways, and they will contract by reflex and constrict breathing for an asthmatic person. Allergic reactions can also inflame the inner parts of the airways, and a similar constricting action can take place. Note that bad environments actually do not cause asthma. The environment provides triggers that keeps asthma episodes from recurring. Triggers to asthma at home are many, as mentioned earlier, of industrial and biological origin, and like cigarette smoke, even introduced by residents themselves. So a wide range of environmental parameters would need to be tracked to evaluate its impact on asthma. Medication basically tries to relax those breathing airways we saw earlier that have contracted and constrict breathing. Severe asthmatics need to carry inhalers. Failing that in time, or overwhelmed by triggers in a bad episode, emergency room visits and hospitalization becomes inevitable. Breathing Stephen, whom we see here, was born severely asthmatic, but is actually a marathon runner and keeps a fascinating blog where he posts his medical bills, which happen to be covered by Medicaid, but run in the tens of thousands of dollars. Enough, certainly, to probably fit a good part of his house with FIRE-certified triple glazed windows. Looking back at Baltimore to get an idea of the impact of asthma in the city that Passive House might be able to help with. In this diagram, we are seeing in gray the whole city's asthma prevalence over 13 years. And in the two colors are two neighborhoods, Curtis Bay and Brooklyn. And you'll see that the city's line is within a fairly narrow range, while the neighborhoods go up and down quite a lot. Well, between 2008 and 2010, new control measures were applied to nearby coal-fired power plants that shaved off something like 45,000 tons of sulfur oxide emissions, 10,000 tons of nitrogen oxide emissions, and about 1,000 tons of PM10 emissions. I don't have any numbers for the PM2.5 emissions that would also probably be accompanying these pollutants. As soon as the air pollution was removed, you can see where the dotted lines are. Asthma incidents in Curtis Bay and Brooklyn dropped. These neighborhoods, few homes, if any, would be able to mitigate that kind of air pollution. And even Passive Homes, with their air filtration and balanced ventilation, would be able to deal with some, not necessarily all. We might have to find some new tricks to get Passive House to deal with some of the air pollutants. But we can because of the mechanical systems that we use. Okay, so finally, I'd like to sort of take a look at also the impacts of, in terms of cost one of the main factors driving high asthma hospitalization and emergency room rates in Baltimore is poverty, linked to many conditions that worsen asthma, such as poor housing conditions and lack of access, limited access to medication. The city's total bill is a staggering $33 million a year. But the point to remember is this, that even if all the bills are picked up, caregivers will lose work hours, children will lose school days, and these negative impacts are real and critical to understanding the full impact of asthma and the human suffering, as well as dollar costs that Passive House might be able to mitigate. We've seen how important the indoor air environment is in the health impact of Passive House, and I would like to now turn over the presentation to Tom.
Thanks, Timmy, for your presentation. I'll link in here with our actual study that we carried out of Breathe Easy Homes in Seattle. I was put in charge of creating a mixed income community in 2001. We already had an architectural and engineering firm working on it. And I personally had an interest in creating a green community. And it turns out the architects and engineers we had working with us were really talented and very interested in working on green development. And when I say green development, ours was both the housing and the site. So we were working on with an existing public housing project, 120 acres, and we started looking at what it was we were doing, and what one of the things the residents told us right away was that indoor air quality was a big issue in a low-income neighborhood. In Seattle, the incidence of asthma was twice as high as it was with the general population. So we went about creating a townhouse community. We were in charge of designing and building 600 of the rental units. Here's an example of what they look like. And then we did design guidelines for 600 of the market rate units, which we required them to be energy efficient also. But it was with the rental units that we had our greater say in terms of what we could do with them. And here we were thinking of turning it and making it green, and we added health functions to our work. So we designed the 600 units, the regular 600 units, with a lot of the standard features that one put into a greenhouse and Energy Star house at the time. This is about 2004 that we were doing this. The standard low VOC paint, the kinds of things that people are very familiar with. But then with the Breathe Easy houses, and we were going to build 35 of those, we started to add other features. Positive pressure house ventilation was the most important one. We added actually insulation to the under the slab. We then went about finding the people to live in the units, which was a challenge. We started building the housing, and that was actually quite a positive experience. The construction crews really got the idea of what we were doing. They did not smoke in the house. They were very supportive of what we were doing. The key element that we added to the Breathe Easy homes was fresh filtered air ventilation. But at the same time, we also did, put walk-off doormats, gave the families HEPA filter vacuum cleaners. The families had to agree, and this supports that slide Timmy just had to agree not to smoke in the units and not have furry pets. So we had doctors working with us and tracking the families. And so we went about and recruited families to live in the units. This particular phase was 35 units, and we had some. It was a challenge, to believe it or not, to find them. But once we found the families, a month before they moved in, they were given a physical. A year before they moved in, they took a physical. A month after they moved in, they had another physical, and then a year after they had moved in, they were given a physical. So then the results are quite encouraging, and this was all peer-reviewed studies. So the old house where they had lived previously, the first issue was the symptom-free days. Out of a 2-week period, there were only 7.6 symptom-free days, so that's less than half of the time. But then in the new home, there were only there was big improvement of 12.4 symptom-free days. As we've seen, urgent care visits are frequent with people with asthma. In the old homes, there were more than once a week. In the new home, there were 20.6 urgent care visits for the families. And then one of the key indicators that got the researchers very excited about the results was that in the old home, on a scale from 1 to 10, with 10 being an improvement, they went from quality of life from 5 to 5.8, which was made everybody very excited. This was roughly a $6,000 upgrade to the house. So it in effect, we've seen some of the numbers. It pays for itself pretty quickly in terms of the cost of the society. So just this, I wanted to put in my little commercial plug. This is all contained in a book that I've written that just has come out about High Point. It's available, The Inside Story, Seattle's First Green Mixed Income Neighborhood. And so more details about the study and what we did, how this whole project came about are in there. So that's it for me. I'm going to turn this over to Monty now. Thanks.
Hi, my name is Monty Paulson. Thanks for that, Tom. Really interested to see the book. I'm a pass-fail specialist at RDH Building Science. I'm going to try to talk a little bit about the building science that may have driven those improved outcomes there in Washington State, and that might point to some solutions for us all going forward. When we look at threats to indoor air quality, we realize most of us spend 90% of our time indoors. It's a somewhat depressing figure, and one that some of us are trying to do better at, but it means that the indoor air quality really affects our overall lifetime health, whether how we have asthma or not. And we should realize that we face indoor air quality threats both from inside and outside our homes and other buildings. So what are those threats? Well, cigarette smoking is number one. And if you still smoke in your home, that's your number one problem. And all of the remaining problems are somewhat less critical for you. Fortunately, most homes in North America have stopped smoking indoors, and it's made a huge difference to quality of life. It's also showed us that we can make progress on some of these things. Off-gassing of carpets and furniture is another huge issue. Again, not as big as it was a few years ago because there have been regulations in place to limit the amount of formaldehyde that can be off-gassed in materials, but it's still an awful lot of sense to make sure there's a breathing period when building a new home to allow materials to reduce the amount of off-gassing that's happening. The next big one, once we stop smoking, is gas appliances in the home. That big Wolf stove is basically, when running without full ventilation, is basically like living alongside a busy intersection. The same Leakage of gas can happen from hot water heaters and furnaces and other appliances. There's a few great new studies, including this one from UCLA, about the effects of gas emissions in buildings that I urge you to take a look at. Simply, something as simple and seemingly benign and friendly as baking a cake in the oven can create a peak nitrogen dioxide limit of 230 parts per billion. Now, to put that number in context, when we look at outdoor standards, they're around 100. There aren't indoor standards in the US, but there are indoor standards in Canada, and that cake is double the advised indoor standard. And things like nitrogen dioxide are particularly damaging to children. They have bigger lungs relative to the size of their bodies, and their brains and other organs are still developing. This chart and these numbers come from a great report by Rocky Mountain Institute, also looking at the health effects from fossil gas stoves in homes. Other indoor air threats, especially for people who do have asthma, and I would add that my 12-year-old does, and so I'm learning to deal with that as well, are dander from pets, vermin, mice, mold, and dust mites are real issues. And cooking particles are issues. And cooking particles are the funny one, right? Because if you smell some of these other things, your body sort of says to you, this is not good for me. When you smell that bacon burning, your body says, ooh, this is good for me. And it is good for you from a putting on weight perspective, from an evolutionary perspective, but breathing the materials themselves are not so healthy. Similarly, a lot of cleaning products are still off-gassing materials, and candles and scented products. People sometimes talk about cooking, cleaning, and candles as the three ways to improve indoor air quality by the occupants. Now, as we mentioned, there are also threats outside the home. Tire particles and vehicle exhaust are huge. This really showed up clearly on those maps Timmy showed at the beginning, where you could see the increase in PM 2.5 right along the freeways and their main arterial roads. Unfortunately, we build an awful lot of affordable housing, rental housing on arterials, therefore putting this housing in the worst air quality that exists in some urban regions. Pollen and dust, particularly tough if there are allergies or asthma or other pieces like that. And of course, industrial particulate. And Timmy's slides showed these as well. Incinerators, power plants, oil and chemical plants, some factories. And then finally, we're seeing as climate change introduces really large wildfires in some parts of the world, smoke and long distance particulate pollution. This is a photograph of my town, Vancouver, on the left, and Calgary, Canada, on the right, after some big forest fires. And these conditions stayed with us for about a week after those major forest fires. And this is a regular event in many parts of the world at this point. And so merely exchanging outdoor air with indoor air in these environments doesn't necessarily make things better. So what strategies might we pursue to improve the situations? We're going to look at two things: source control, that's mostly within the occupant hands, and high performance ventilation, and some other building science strategies that are more in the building. Let's look at the behavior first quickly, because most of these are kind of obvious. Well, best thing you can do for indoor air quality is don't smoke, or at least don't smoke indoors. Keeping animals, pets outdoors can be really healthy, especially if there's asthma or allergies or other sensitivities in the household. From a cooking perspective, cover the frying pan. It's that simple. If you cover the frying pan, the vast majority of the time, you will reduce cooking emissions pretty significantly. Choose natural cleaning products, avoid scented products, and if you can afford to do so, replace the gas stove or replace the open flame gas water heater. There are induction stoves that are fantastic, and most of the kind of high-end chefs and other cooking professionals are finding induction is actually much easier to cook on, much easier to control than induction cooking. Building performance-wise, there are also clear steps, and you saw some of these on the Seattle examples, but I want to just take a minute and talk about why they work. So air tightness is one of the huge factors that can make a home healthier. You have a strong air barrier that prevents the exchange of outdoor pollutants and indoor pollutants, and therefore allows you to ventilate and clean out some of the indoor pollutants. But there's another reason air tightness matters. Most of you who've taken apart a home or renovated a wall or something have seen this, the sort of black marks around the edge of your insulation comes up against studs, and if you pull it back, you may very well likely see mold on the outside or the inside of the sheathing on the outside of that wall. What's happening here is an inadvertent exchange of air. It's air leakage, and it's really important to understand the effect this has on air quality. So think of the house as exhaling. warm, moist air in the house relative to outdoors flows into the wall when the house is pressurized. And the house could be pressurized simply because it's a little warmer than the outside air because it's somewhat closed in, especially in wintertime. So you're pushing warm, wet air into the wall. It hits the colder sheathing on the outside. That water condenses and leads to mold. And that's exactly what's happened here is air has slipped along those edges of those studs because there's nothing to stop it from doing so and condensed along the outside sheathing. Now, you decide, it's a little moist inside. I'm going to turn on the bathroom fan. I'm going to turn on the kitchen fan. Or maybe I'm just going to run a dryer, which is effectively a big fan. What you've now done is start depressurizing the house and pulling air back into the home through the same cracks you pushed it out of the home when the house was pressurized. This means your fresh air, the air you're breathing, is coming through the mold you created when you were depositing moisture there in the other condition. And this is the key piece about air tightness. The air you breathe enters your house here. And this is what we want to get away from through these other strategies. So, number one, a really airtight enclosure. Number two, balanced ventilation to every room. If you simply take the pressure off, you're not pushing moisture into the wall and pulling it out because you have another path, a planned path of air coming into the house and air going out of the house at the exact same rate. You literally don't create that pressure through the walls to the same degree. That equal supply and exhaust does not force air through the assemblies. This is a kind of cutaway diagram of a typical heat recovery or energy recovery ventilator. Here's some photographs of residential style energy recovery ventilators. The one on the left could serve like a 2-bedroom home. The one on the right could serve a 4-bedroom home. And there are much larger ones for apartment buildings and other circumstances. So these appliances come in all sizes and scales, but having them in a well-designed system is the key. Okay. You've got air tightness, you have balanced ventilation in every room. Now, of course, you want to filter that incoming air. Again, we talked about the skies over Vancouver during the last smoke event, but you could have the same sort of thing happening if you happen to live next to an arterial road with less visible but higher particulate all the time. This is a new filter and a replacement filter after just 1 week in one of those smoke events recently. We also see the need to change filters on ventilation devices much more often when people live near arterial roads or some other form of localized pollution. The next step that's really important, and again, Tom mentioned they put some insulation under the slab and other pieces. What they were doing is eliminating thermal bridges, because where that thermal bridge is, and many of us have lived in homes with single pane aluminum windows like this, that's the coldest spot. So that's where the air condenses. Where the air condenses and continually gets wet, it leads to mold. Many of us have lived with this. The thermal bridging is a mold factory. The window is inconvenient because you see it, but what happens in the wall, under the slab, in the attic, around mechanical penetrations can be more dangerous because you don't see it. The exact same phenomenon is happening out of sight. And of course, if it gets cold enough, the thermal bridging can turn to ice. Finally, we want to manage humidity. We produce humidity in every home normally. You take a shower, you boil some water for pasta, whatever you might do. And it's important to remember humidity is something we're looking for a Goldilocks condition. We're not looking to overdry the house because that can lead to health effects, nor do we want a very, very humid environment inside because that can lead to health effects. We're looking for something in that midpoint range and designing a ventilation system that considers the humidity of the outside air, which of course is going to be much higher if you're in a place with hot, humid summers, much lower if you're in a dry desert environment or up in the Rockies or something like that. So understanding the climate you're building in and designing ventilation to produce the right humidity is a key piece. And then finally, it's important we start to monitor these effects. We really haven't monitored indoor air quality very much anywhere, but there's a new squad of mobile sensors that provide real-time feedback via mobile apps. And using these, one can learn to recognize important metrics such as relative humidity, particulate matter at various sizes such as PM2.5 or CO2. It's worth noting that many other nations are well ahead of the US and Canada in terms of being aware of PM2.5 and CO2. This is the default display on a thermostat in a new apartment outside Beijing. And this is very typical in China and increasingly so in Europe, that customers are demanding an awareness of these indoor air quality metrics inside their house. So just to recap quickly, once upon a time, fire ventilated our homes. We started building, moved from outside to inside. We started putting our fire in boxes with exhaust, chimneys. And what happened was we created this pathway. And as long as our homes were still really leaky, that combustion air came into the home and the fire was the ventilation. The fire was pulling air through our homes, through big cracks under doors and around windows and pieces like that. As we started making our homes more airtight and started replacing the fire with radiators and other heating devices, we started putting in things like bathroom fans and kitchen fans. And that led to pulling air through the walls in so many ways. And probably there's a correlation between this move towards kind of mid-century assemblies and mid-century construction design and the rise in the rate of asthma and other respiratory illnesses. And what we're trying to move to now is more insulation, perfect air tightness, and a heating recovery ventilator or energy recovery ventilator where the air comes in on purpose right to the ventilator and then out through the ventilator. And so we get rid of all that other equipment and create a much healthier home. So to pull this together, we have these strategies that can improve indoor air quality. We can adopt the behavioral strategies today, big ones on don't smoke, cover the frying pan. Of the building performance strategies we've listed and looked at, and you saw many of these effect in the Energy Star Healthy Homes in Seattle. These are part of the Passive House standard. If you build a Passive House either to the international standard or the US standard or to the EnerPHit renovation standard, this is built into the system and there is quality control around these metrics. And so Passive House, in a sense, for many of us, becomes the shorthand for good indoor air quality. Rather than depending on a field of professionals to get everything just right, you've got a certification standard that's going to make sure you get these pieces right. Thank you very much. And let me turn this back over to Timmy to wrap us up.
Thank you, Tom and Monty. I hope we all gain some insights into the way a superior indoor air quality can lead Passive House down the road of the Breathe Easy Homes of Seattle and dramatically improve the quality of life of asthma residents as well as others. And in fact, I think Monty pointed out the very important point that Passive House is halfway there already. We're kind of doing some of this stuff. Well, Baltimore may not have Breathe Easy Homes. In Harlem Park neighborhood, we have a pharmacy that's chosen to call itself Breathe for Sure. Of course, I found this a little bit funny, but it put the very idea of breathing Baltimore into doubt. But you know what? What I'd like to do is to talk about the building next door, which, if you notice, is a vacant. It's one of between 16 and 40,000 vacant row homes in the city. This map of Baltimore's vacant buildings has the same butterfly wing form that we that we might recall characterize the asthma and low median income maps. Indeed, according to the Environmental Integrity Project previously mentioned, that the one of the demographic measures most closely correlated with asthma was indeed median income, median household income. These vacant row homes on Franklin Street in the Franklin Square neighborhood of Baltimore are a part of a very beautiful urban fabric of the city, as are most of the other vacant row homes. They face the threat of demolition, but should be brought back to life in order to revitalize, not gentrify the city. Many of us in Baltimore are currently working on retrofit Passive House affordable housing designs for vacant row homes and hope to gain enough momentum to save neighborhoods from being razed. Just out of interest, here are two classes working together that I taught: an architecture design studio from MICA, designing affordable housing units from vacant buildings, while another class of Hopkins students working with me on energy models, both on WUFI as well as Athena or embodied carbon, teamed up together and figured out great solutions for passive house, affordable housing projects based on vacant buildings. Now, if we were to put costs to these projects about 200 to 300K dollars per dwelling unit, a 50% Baltimore median income household may only be able to secure a part of that, like 150 maximum is what I sort of guesstimated, leaving a funding gap of about 100 and 150K per unit. But Baltimore's asthma bill is $33 million, right? It could alone equal to the financing of 220 homes. So that's to say that if a proven fact-based link between health and passive house can be established, there can be funding streams from that are not available at the moment that may support our cause. As a last note here, so this is my kind of formula for Baltimore at the moment. Vacant homes, we've got loads of them. We are developing skills and retrofit passive house affordable housing. And we can claim that these will result in a sustainable environment, housing that's affordable for the community, climate resilience, and generally an improved quality of life. What I would like to do is this. I would like to add to this list of claims, right, in a substantiated sort of way, that improved public health is one of the outcomes, and that indeed passive house could be seen as part of a public health strategy. And with this point made, I'd like to pass it on to the audience and look at the questions that you have for us.
All right, thank you everyone. And I saw that quite a few questions came in through the Q&A as well as the chat. So we have about 10 minutes for Q&A, and I will turn it over to our awesome panelists from here.
Okay, can you hear me, right? We have a few questions. It's one about Indoor Air Plus required for paid certification, right? Yes, that's true. As of 2018, definitely are. There's two questions from David. David Solomon, do you want to take them, Monty?
Sure. Hi, David. Hi, everybody. Thanks, everybody, for being here. I enjoyed putting this presentation together and enjoyed working with Tom and Timmy in this process. You know, David's question about COVID-19 is kind of the obvious one. We focused in this panel on asthma because we have some data for it and some examples for it. COVID-19 is really new. I don't believe there are any studies out yet that can look at COVID-19 in a passive house versus a non-passive house, and it might be years if we ever see that. But what we know is that because passive house buildings don't do recirculation, because they do filter the air somewhat, if you're running an appropriate amount of fresh air through every room all the time, that gets us pretty close to what we consider is the best practice for indoor air quality. You know, passive house is 100% fresh air to 100% of the rooms running 100% of the time. The largest concerns from ventilation engineers right now have to do with recirculation and filtration. And recirculation is particularly an issue in some office buildings and some commercial buildings where, in order to prevent having to have very high air conditioner or heating rates, depending on the season, you know, they're taking some of the air and sending it back with a mix of some fresh air. And that mix of fresh air and recirculated air is often determined by humidity or temperature controls with some minimum where there's at least a certain amount of fresh air coming back for people to breathe, so it doesn't become a lack of lack of fresh oxygen or too much CO2 or too much of some other particulate. The research, of course, can also be redistributing airborne virus such as COVID-19. So, or the virus that causes COVID-19. So if you're at 100% fresh air, and if you have no air exchange between one unit or the other, or a supplier exhaust, which you do with a Passive House design system, you've got the best baseline to work from to improve your health outcome. Now, if there's somebody in your unit with COVID-19, the ventilation is not going to prevent it from spreading to one person or the other in the same room, or in the same compartment, you know, if it's in a larger space. There is quite a bit of research around more aggressive filtration, but there's nothing on the market that can absolutely address these kind of viruses and filtration. And even if there is, the research that's looking at it suggests you have to slow the airflow down fairly significantly for those things to work. So until we have some kind of magic filtration, which is no closer than a vaccine, 100% fresh air is probably our best strategy. And while that is certainly doable in any building, it is required by the Passive House standards. Does that come close to answering it, David?
Yeah. Can David even turn on his speaker? Not sure. Right, and there was also a session in the North American Passive House Network conference recently on why COVID-19 hates Passive House. That was the title of their session, and Monty, they discussed exactly what you pointed out, the non-mixing nature of Passive House ventilation and its speed. In terms of filtration, I heard rumors via a mechanical engineer that HEPA filter is the one of choice. It may simply be because it's the best we have. I don't know that it's been tested. I don't think, you know, if it has, it's not been announced. Shall we move on to other questions? David also asked to address the increased ventilation rates. You sort of addressed that, Monty, I think.
Maybe I'll add one thing. I'm trying to be conscious of time. You know, realize that ventilation is not a more is better scenario. Too little ventilation is obviously not great for indoor air quality, for health, and can lead to problems, but too much ventilation can lead to overly dry air, different health effects, different building problems. And so historically, our approach is to find that sweet spot using various calculation charts and tools, but looking for a ventilation rate in residences at least of, you know, 0.3 to 0.7 air changes an hour, something like that is often deemed ideal. You know, the hospitals or medical facilities often have rates of 8 air changes an hour, 10 air changes an hour or higher, but those are for very specific rooms that have very high likelihood to have these sort of contaminated particles. There's not generally as much focus on bringing in clean air to those places. You assume, our entire ventilation strategies are assuming that outdoor air is fairly clean. But again, as you have more particulates like the data that Timmy showed, or if you're just living near a freeway, that's probably not true. However, you don't need dramatic filters to winnow those down. Something as simple as a MERV 13 filter, which is required in Passive House, and it's kind of the sweet spot between not creating too much pressure backup, like you might get with a HEPA filter or more aggressive filters or multiple filters, but filtering out quite a bit of the particulate, again, not 100%. Probably the more practical issue for most buildings is simply maintaining the filters. You know, if you have a fire event, if you live near a freeway, you want to be changing your filters every month, maybe even more. If you live in a place with pristine air, we find in a lot of Passive House projects in rural environments, they can change them once a year, and they're barely as dirty as an urban filter is after 2 or 3 months. So keeping the equipment you have in great condition is as important as what filter you picked in the first place.
Yeah, so that leads perfectly on to another question from attendee 12157.
Oh, right.
about what does the passive house system do to clean outdoor air if it is not meeting standards? Are there add-on units of additional filtration, like bag filters, which provide less backup pressure, that need room? Can stuff like that be added?
I mean, there is a minimum filtration level for passive house ventilation equipment, and frankly, for lots of non-passive house ventilation equipment have good filtration. Quite a few of our projects during the smoke events of the last few years have looked at either adding a second additional filter or a slot in which one could place a second additional filter during a fire event, where our intense pollution is limited to a short period of time, like a week or two a year. That would be more complicated if you live next to a freeway because your event's every day. So, you know, you can create additional filtration, or you could add other layers. I'm not sure you would do it specifically for something like a coronavirus or a viral threat. I think you always have to balance that, creating more static backup, more pressure resistance on the system versus more filtration. So again, in most cases, simply changing them more often is the answer. And keep in mind too that all of the passive house standards require operable windows. So when you don't have extremely dirty outdoor and you are in something like a pandemic, you have the ability to rapidly increase the rate of ventilation in your building by leaving the HRV and all that system running, providing that great baseline of fresh air, and just open the windows and get a whole lot more wind possible.
I wanted to add, you know, a field problem that we had when we did these first 35 houses. It turns out that we put the filter in the attic, and it was kind of hard to get to. So the maintenance people weren't getting to do it, to change the filter very frequently. And we finally figured out, and then we did another 25 Breathe Easy homes, and we made the filter much easier to get to. So it's just a simple, practical solution, but sometimes it gets lost in all the excitement about what you're trying to do.
We have one more question in the chat, which we haven't answered. Again, Monty, you might be the best person for this. We have a thick layer. This is a question from Mohammad Abbasi. We have a thick layer of insulation in passive house. What would be the impact of the insulation off-gassing into the interior space?
Well, it depends on what it's made of. If it's mounted towards the interior and you have a lot in there, you would certainly want to let it off gas before covering it up, if at all possible, and just ventilate the building. What tends to happen with most materials is there's a dose response curve where there's a heck of a lot at the start and then it trails off slowly over time. This is why a lot of projects do things like put the rock wool or the fiber insulation on the outside of the sheathing, where it's essentially an outside product. And then for homes that are particularly sensitive, on the inside, they'll do something like recycled cotton, recycled natural fiber of some sort of insulation, so there is no off-gassing. We've actually done 2 single-family home passive house projects for chemically sensitive or air sensitive clients, and that's been our approach in both times, to keep the construction site incredibly clean, to use a natural non-off-gassing insulation on the inside and a more robust insulation such as rock wool on the outside.
Great. So these, for example, would be features we'd like to build into the next passive house version of the Breathe Easy homes in Seattle. How are we doing for time?
Hi, Timmy. Just sorry to interrupt, but we do only have a minute left. So if you have questions, feel free, Tom, Monty, and Timmy, to put your contact information for folks in case they do want to reach out to you. We do have a full day of conference tomorrow.